A small security team starts by entering a domain or IP range into the product's simple interface. The system springs to life, silently discovering internet-facing assets across the web's hidden corners. It begins with Shadowbroker, the geospatial intelligence engine, which activates its 60-plus OSINT feeds to map devices, services, and vulnerabilities tied to that domain. Like a radar sweeping the internet, it pulls in data from sources like Shodan Senses and TLS certificates, but instead of dumping raw text, it visualizes findings on a global map with layers for threats, recent changes, and exposed systems. As Shadowbroker builds its initial inventory, crawlee-python kicks in to scrape websites, APIs, and public documents associated with the target. It mimics human browsing to bypass antibot protections, extracting details like subdomains, API endpoints, or accidentally exposed documents. This data feeds back into Shadowbroker's server-side recon toolkit, which runs automated checks for vulnerabilities, misconfigurations, or compliance issues. Every finding is cross-referenced with CISA KEV lists and sanctions databases to prioritize risks. The team's dashboard, powered by Tremor and Recharts, updates in real time. Tremor's pre-built React components render clean, accessible panels showing asset counts, threat heat maps, and trend graphs. Recharts overlays D3-driven visualizations like a timeline of newly discovered assets, or a bar chart comparing critical vulnerabilities by type. If Shadowbroker detects a sudden spike in exposed devices, the dashboard highlights it with an animated pulse, drawing the team's eye to potential breaches. Underneath, Grafana handles the monitoring backbone. It aggregates logs and metrics from Shadowbroker's backend, setting up alerts for anomalies like new ports opening overnight, or a surge in traffic from known malicious IPs. When the team drills into an asset on the map, Grafana's templating system fetches correlated logs and performance data, showing how that device has behaved over time. Alerts can trigger automated responses, like quarantining an IP or notifying the team via Slack. No data leaves the self-hosted stack. Crawlee's scrapers route through Shadowbroker's secure backend, avoiding third-party APIs. Tremor and Recharts render everything client-side, with Grafana managing access controls. The result is a unified view of the attack surface, from a satellite-like global map down to individual device configurations, all updated live and presented with minimal lag. Small teams get actionable intelligence without noise, knowing exactly what's exposed, where it's vulnerable, and what to fix first. When a crawl request fails or a service endpoint goes unreachable, the system applies an exponential retry policy with automatic fallback to cached results, ensuring the monitor stays resilient against transient errors. Here's how a single request moves through the system, illustrating the full data flow. Imagine a small security team member right-clicking a geographic location on Shadowbroker's map to initiate an asset discovery scan. The request begins in the front end, where Tremor and Recharts components handle user interaction. Tremor's dashboard wrapper passes the geospatial coordinates to Shadowbroker's FastAPI backend via an authenticated WebSocket connection. Shadowbroker's server-side recon toolkit then validates the request using local operator authentication, ensuring no sensitive data touches third-party APIs. The backend triggers crawlee-python through a gRPC service call, specifying the geographic bounds and asset types to scan. Crawlee initializes a Playwright browser instance with proxy rotation, mimicking human behavior to avoid detection. It scrapes Shodan, certificate transparency logs, and other public datasets, returning structured JSON results to Shadowbroker. These results include subdomains, open ports, SSL certificate details, and vulnerability banners. Shadowbroker processes this data, cross-referencing it against CISA KEV feeds and historical BGP data stored in its local PostgreSQL repository. It then generates a threat score for each asset using a Python-based scoring engine, storing the final inventory in the same database. For visualization, Shadowbroker's Next.js frontend fetches the processed inventory via REST APIs, using Recharts to render threat score histograms and Tremor to build interactive map layers. When the user selects specific assets, Recharts components request granular data through Shadowbroker's FastAPI endpoints, which in turn query the PostgreSQL database using SQLAlchemy ORM. Grafana enters the flow via a separate data source configuration, polling Shadowbroker's metrics endpoint every 15 seconds for PROM-QL-compatible telemetry. This includes asset count, active scans, and threat score trends, which Grafana visualizes in a dedicated dashboard alongside logs from the crawly scrapers. When a threat score exceeds a threshold, Shadowbroker publishes an event to a local MQTT broker. Grafana's alerting system consumes this event, triggering a Slack webhook configured in its UI. The alert includes a link back to the Shadowbroker map interface, pre-filtered to the affected geographic region. Throughout this chain, no component shares data outside the local stack. Crawly's scrapers never touch public clouds, Shadowbroker's backend proxies all third-party queries, and Grafana only accesses pre-aggregated metrics. Each handoff is governed by strict API contracts. Crawly returns scraped data in a predefined JSON schema. Shadowbroker's APIs enforce content security policies, and Grafana's data source expects time series data in a specific format. Storage entities remain siloed, with PostgreSQL handling asset metadata and Grafana managing its own temporary metrics cache. This separation ensures small teams maintain full control over sensitive reconnaissance data, while still benefiting from modern visualization tools. Start with Shadowbroker as the core intelligence engine. Set up its FastAPI backend and MapLibGL frontend locally using Docker Compose to handle the geospatial aggregation. This gives your small team a centralized map interface to visualize assets immediately. Before connecting live feeds, test the core data pipeline by mocking sample OSINT inputs, simulate device locations, conflict zones, and synthetic C2 servers. Verify that the right-click country dossier feature works with static data first, ensuring the entity graph expansion doesn't break with minimal nodes. Next, layer in crawlee-python for asset discovery. Build a basic scraper to pull public asset directories like DNS Dumpster or Senses via local proxies to avoid rate limits. Use Crawly's built-in rotation of user agents and proxy pools to mimic real browsing patterns. Integrate findings back into Shadowbroker's server-side recon toolkit. Test the pipeline by feeding it known subdomains of a test domain watch for false positives in the geospatial overlay. If a scanner misattributes an IP geolocation, adjust the backend's SSRF guards to prioritize max mind over less reliable feeds. For visualization, start with Recharts to build simple bar graphs showing daily asset counts and risk scores. Embed these into Shadowbroker's Next.js dashboard using Tremor components for layout consistency. Test responsiveness by shrinking the map interface to mobile sizes. Ensure no data layers collapse unexpectedly. Use Grafana's alerting later, but first get the raw data flows stable. Local development uses Docker to containerize each service. Shadowbroker's API, Crawly's scraper workers, and the React frontend. Use env files to manage API keys for local testing. Never commit these. For background jobs, schedule Crawly scrapes every 6 hours using Celery or Python's ape scheduler. Shadowbroker's data layers refresh on a similar cadence. Monitor log outputs to catch memory leaks in the MapLibGL rendering during long sessions. Production deployment starts with hardened Docker containers in a Kubernetes cluster. Use a managed PostgreSQL instance for asset inventory persistence. Deploy Grafana with a read replica to handle the alerting load. Set up auto-scaling for Crawly workers during peak scanning hours. Use Let's Encrypt for TLS termination at the ingress. Security test the deployment by attempting to SSRF through Shadowbroker's backend. Verify that the proxy blocks all unexpected outbound requests. Finally, train the team on Grafana's alert annotations to correlate attack patterns with asset changes. Keep the feedback loop tight. If a new asset appears on the map, it should trigger a Crawly deep scan within minutes. Prioritize simplicity. Small teams can't manage unnecessary complexity. Every component must have a single, clear purpose in the attack surface pipeline. To deploy this attack surface monitoring stack, start by setting up Shadowbroker's backend with Python and FastAPI. Clone the repository, install dependencies via pip install our requirements.txt, then run python server.py to start the backend. The frontend builds with Next.js using npm install, followed by npm run dev. Ensure MapLibGL keys are configured if needed, though the default setup uses open layers. Shadowbroker's README emphasizes no external API dependencies. Sensitive queries route through its backend with SSRF protections. so configure allowed origins in environment variables to restrict access. For asset discovery, integrations with crawlee-python require installing the package via pip install crawlee. Initialize a crawler using npx crawlee init, then extend the base class to define scraping logic. Use Playwright Stealth plugin for rotation of proxies and user agents as outlined in Crawlee's documentation. Pair this with Shadowbroker's server-side recon toolkit by posting discovered endpoints to the recon API endpoint for instant geospatial mapping. Visualizations rely on Recharts and Tremor. Install Recharts with npm install Recharts, then wrap components like line chart or geopath for asset trend graphs. Tremor components are added similarly via npm install at Tremor React, using card primitives to build lightweight dashboards. Both libraries depend on React, so ensure version alignment. Recharts requires matching React's versions. Grafana ties metrics together. Run docker run p3000 grafana for a quick setup, then configure data sources via the UI. Shadowbroker's telemetry can feed into Grafana via HTTP data source, or by writing to a shared PostgreSQL database. All components are open source. Shadowbroker uses an unspecified permissive license. Crawlee is a patch 2.0. Recharts and Tremor are MIT. Grafana is a patch 2.0. Self-hosting is free but requires infrastructure. Shadowbroker's real-time layers may need GPU acceleration for large datasets, while Grafana's dashboard complexity scales with browser performance. Today, a developer could run Docker Compose up on a predefined stack combining these tools. One challenge: how do you securely manage authentication for crawlers accessing sensitive or rate-limited targets?